Okay, everyone, another example of vector multiplication in physics is actually in electromagnetics. There is a law that if a electrical charge cuts, imagine this is an electrical charge, if it cuts the B's, and the B's are actually this B, this is a magnetic field. So the B is a magnetic field, and if in these B's, these are each B, these are all magnetic fields. So if it cuts the magnetic field lines, then a force is applied to it. So this, of course, if this v, the velocity of movement of this electrical charge, which I call it q, of course it's called q, if the velocity is this way, it would not cut any b's. If it's this way, it cuts some b's, and if it's this way, it cuts the maximum b's, right? So you can easily see in here, so therefore by cutting the b's, the F is applied to it. So obviously the bigger the angle is, the greater the result of this multiplication will be. What happens is that the force created in here is a vector, of course, which equals to q. Q is just a constant, the amount of this electrical charge, the velocity times b. B is a vector, b itself is a vector, velocity is of course also a vector. So the field that has a direction, of course the magnetic field we know has a direction. So anyways, this is now what is happening here. So I just explain it one more time. This is our electrical charge. Okay, this is our electrical charge, and this is the V. Let's say it's going this way, and of course this is the direction of the B, right? Like, this is the B itself, which we can see. This is B. These are all the B's in this direction. So V times B, the forefinger goes from V to B, gives us the F, which is the result of this multiplication, and it's a vector. So the vector F in this case is coming out of the page, is coming out of this. So I'm going to show it like a dot because it's coming out, and it's RF. So the F is coming out in this case. We will learn more details about this as we go, as we do the electromagnetic chapter.